Hello all. In this video I'll be presenting the solutions to the review collaborative for chapters 4 through 6. Let's go ahead and jump right in. The first problem asks us to simplify this expression. Notice that there is no equal sign, so it's not an equation, just an expression. So to simplify it, we'll be doing things like clearing parentheses and combining like terms. So we'll start off with clearing parentheses. So for that we're going to use the distributive property, so we're going to distribute this 2. So 2 times x is 2x minus 2 times 6, which is 12. On this next part, we're distributing just a negative sign, so that'll have the effect of multiplying by -1 or changing the signs of what's inside. So this positive 5x will become a negative 5x, and this positive 6 will become a negative 6. Here, when we distribute the 3, it's important to note that it's not a 3, it's a negative 3. So we're multiplying negative 3 times 3x, which is negative 9x, and then negative 3 times positive 4, which would be negative 12. And then we're going to want to combine our like terms, so that would be our x terms. And let's see, I'll go ahead and combine these two right here. So that would be 2x minus 5x is negative 3x. And I'll just copy this other one over. And then let's combine these two like terms right here for the constants. Negative 12 and negative 6 would be negative 18. And I didn't do anything with that one yet, so I'll copy that one over. And then combining the last two x terms, negative 3x and negative 9x would be negative 12x, adding together those coefficients. And negative 18 and negative 12 would be negative 30. So that would be the simplified version, and I'll go ahead and box that answer. Alright, moving on to number 2, working with functions. If f of x equals 2x plus 7, then find f of negative 3. Notice that this negative 3 is inside the parentheses where that x is, so essentially when they tell us to find f of negative 3, they're saying substitute this negative 3 in place of that x, but if we're going to do that, we should substitute it in place of the x's on the other side as well. So this would be 2 times negative 3 plus 7, just taking that negative 3 and plugging it in for that x. And then from there we just need to simplify, so 2 times negative 3, negative 6, and then carry over the plus 7, and negative 6 plus 7 is positive 1. So we end up with the answer, f of negative 3 is equal to 1. Alright, and then a little different from that on part B, when they say to find x if f of x equals 4/3, notice this time the 4/3 is not in the parentheses, so that's not a value of x. They're saying f of x equals 4/3, so we're going to take this whole f of x piece and replace it by 4/3. So this is like a y value in this case. So where the f of x was right here, we're going to write that 4/3. And then we're going to set that equal to the other side, which is 2x plus 7. And now we have an equation, and our job is just to solve that equation. And this equation has fractions in it, so the smartest first step, in my opinion, would be to multiply through by the LCD. There's only one fraction, has the denominator of 3, so we'll multiply every term by 3. So 3 times 4/3 equals 3 times 2x plus 3 times 7, multiplying every single term by that 3, and we do get some cancellation, which is why we do it. These 3's cancel off, and then we're left with an equation that doesn't have fractions in it anymore. So all that's left over here on the left side of our equation is the 4. On the other side we do the multiplication. There's nothing to cancel because there's no fractions. So 3 times 2x is 6x, plus 3 times 7 is 21. I already have the x by itself on this side, so I think it makes the most sense to go ahead and move the constant terms to the other side. So I will subtract 21 from both sides. These will cancel. And then 4 minus 21 is negative 17. That would be equal to 6x. Trying to get that x by itself, it's got a 6 connected by multiplication, so I'll divide both sides by 6, which will make that 6 cancel. And that takes us to our answer. X, which is now by itself, is equal to negative 17/6. So notice the difference between how these work depending on where the number is. If it's inside the parentheses, we're just plugging it in for x. But if it's f of x equals, we're going to replace f of x by that, and then we're going to do some algebra to solve for x. Alright, now moving on to problem number 3. They want us to solve, graph, and write in interval notation, and we've got an absolute value inequality there. So one of the things that you want to remember with absolute value inequalities is before we can remove the absolute value, we have to get the absolute value by itself. So we have this minus 7 attached to the absolute value, so if we add 7 right here, those would cancel. And if we're going to add 7 to one side, we have to do it to the other side as well to keep things balanced. So that would be our first step. And when we're done with that, we have the absolute value by itself. 3x plus 5 in absolute value is less than 38. And then we just want to think about the idea of, okay, so when would an absolute value come out to be less than 38? And the answer is anytime the part inside the absolute value was in between positive 38 and negative 38, it would have an absolute value that was less than 38. Remember that if you're trying to get rid of an absolute value, the only way that's ever going to happen is if you introduce a negative and a positive case. And with absolute values in the less than situation, we can do that with a three-part inequality, which is nice because we can solve that more efficiently than if we separated it into two completely separate cases. So we're going to try and get this x by itself in the middle now. So subtract 5 from all three parts and then simplify. So negative 38 minus 5 is negative 43. That's less than 3x, which is less than 38 minus 5, which is 33. And we subtracted 5, or you could look at that as a negative 5, but addition subtraction never causes us to reverse the inequality. It's only if we divide by a negative that happens. So if you're thinking about that, that's why we're not doing that here. And then we want to get this x by itself in the middle, so we'll divide by 3. That would cancel that 3, leaving just the x. But if we do that to the middle, we have to do that to both sides as well. And that works out better on one side than it does on the other. When I go to simplify this in the middle, I have x. Over here on the right, 33 divided by 3 is 11, so that works out nicely. On the other side, 3 does not go into negative 43, and we're not supposed to go to a decimal unless they ask us to, so we would just leave that as negative 43 thirds, but the x is by itself now, so we can say that we have solved that inequality. So now we'll just move on to the other two things that they asked us to do. One of those is graph, so we're going to graph that on the number line. So you just need to put these two numbers. You don't need to put 0 or worry about scale for me. So just negative 43 thirds is to the left, 11 is to the right. This is a strict inequality, just a less than. There's no or equal to, and that means we'll do open circles on each of these boundary numbers instead of solid. And then where's the x? It's in between those two numbers, so what do we graph? We graph in between those two numbers. And then for interval notation, the interval just goes from the left side, negative 43 thirds, to the right side, which is positive 11. And if these were solid circles, we'd put a square bracket, but since they're open, we put a parenthesis, and that's the case on both sides. So we do that on both sides. So now we have solved here, graphed there, and wrote in interval notation right there. So all three of these parts make up our answer. We've got the solution, the graph, and then the solution expressed in interval notation. All right, number 4. In the year 2000, the number of households with personal computers, or PCs, in the U.S. was 63.88 million, and it was increasing at a rate of about 2.99 million per year. The total number of households in 2000 was 105.96, and it was increasing at a rate of about 1.70 million per year. So in part A, they want us to let C of t be the number in millions of households with PCs, and H of t be the number in millions of households, both at t years since 2000, and they want us to find equations of C and of H. So they say of C and of H, but they've indicated that they want function notation with the C of t and with the H of t. So I'm going to do these in different colors here. Let's do green for the C of t. So we're going to try and do a linear equation, so we want to do like an mx plus b sort of thing for that. So that means we need to figure out what the slope is. So we're going to look at the number of computers or PCs, and we're going to look for something that indicates slope. So we have, the number was 63.8 million, and when was that? That was in the year 2000. That sounds like the y-intercept, 0, 63.88. So I think we just found our b right there. And then it says it was increasing at a rate, so that all sounds like slope. of about 299 million per year, and the per year is something, the per especially is something we often see with slope. So I think we found our m right there for this equation. So instead of y equals mx plus b, we're going to say c of t for our y value equals m times t for our input variable plus b. So c of t equals m, which will be 2.99, times our input variable of t, plus the value of b, 63.88. So there's one of our equations. Now we want to just move on and do the other one. So I'm going to do h of t in purple. We're just going to follow the same idea. We're going to try and write h of t equals in an mx plus b sort of format. So in this case, mt plus b. And so if we find the number for 2000, it was 105.96. So that would be our 0, 105.96 as an ordered pair because our starting year was 2000. So that makes that b. And then they talk about the rate at which it was increasing. So we know it's a positive slope. That's why this one was positive too. They said it was increasing. And we see that per year in there again. So this looks like this would be the value of m for our second function. So h of t is 1.70 times the input variable of t plus the y coordinate of our y-intercept, which is 105.96. All right, so there's part A. We've got our two equations. Let's see what they want us to do next. Use substitution to predict the year when all households will have PCs, and then verify this using intersect on the graphing calculator if you have one, which you do, and you need to bring it to the test, and then round to the nearest year. All right, so if we're going to use substitution, what we want to do is think of these sides are like the y. So we've got y equals here and y equals here. And when you solve by substitution, you want to get one of the variables by itself in one of the equations. So we have that here. We have y equals. So then we substitute this part in for y in the other equation. So this piece right here will replace by the h of t right there. So we're going to take this and we're going to substitute it for the other y in the other equation. So we get 2.99t plus 63.88 equals 1.70t plus 105.96. And I would also argue that this is a good place to start because they said they want to know the year in which all the households will have PCs, so that would be when the number of households is equal to the number of households with PCs, and we took the number of households with PCs, set it equal to the number of households. So now we just want to do the solving. So we're going to step in there and start doing some rearrangement. So I want the t's on the left, so I'll subtract 1.70t here so that those cancel. I'll do it on the other side to keep things balanced. And then since I'm moving the variable t to the left, I'll move the numbers to the right. So I'm going to subtract 63.88 from here so that those cancel, and subtract 63.88 on the other side to keep things balanced. And then we just want to see where that leads us. So these have canceled. If you subtract these two right here, you get 1.29t. And then on the other side, if you subtract the 105.96 minus the 63.88, you get 42.08. I'm not so great at those where I can just whip those out of my head. I actually have those written down somewhere else. So you could use your calculator to do those subtractions if you want. And then I want to get t by itself, so I need to get rid of this 1.29. It's connected by multiplication, so if I divide both sides by the 1.29, those two will cancel because 1.29 over itself is 1, and 1 times t is just t. But if I'm going to do that division on the left, I have to do it on the right as well to keep things balanced. And then I've got t by itself, and on this one, it is telling us to round to the nearest year, so we could go ahead and go to a decimal on this, and if you divide these on your calculator, you get a number that comes out approximately like 32.62. And then they want us to round that to the nearest year. So that would be t is approximately 33. But they don't want an answer for t. They want to know what like calendar year it was. So t was the number of years that have passed since 2000. So what I need to do to get that calendar year is take 2000, add the 33 onto that, and then we get the year 2033. So this should happen in 2033 according to our work and according to these models. All right, they've got one part left for us. Let's go ahead and read what they want us to do there. Predict the percentage of households that will have PCs in 2017 and round the result to the nearest hundredth of a percent. So the first thing you need to do is figure out T. So T is equal to the year they're talking about, 2017, minus the starting year, which is 2000. So that means we're going to be working with a T equals 17 in this problem. The issue that people usually have there is they're like, so where do I put that? Do I put that into the C of T or do I put it into the H of T? And the answer is both. So last time I did this in class before I made this video, I had 21 people working on the collaborative and 5 of them were male. So I asked the class, how would I calculate what percentage of the students in this class were male? And I said, what do we need to know? And they said they need to know how many guys are in the room, and there were 5. And they said we also need to know how many people in the room, 21. And once you get that 5 and the 21, you can do a division there. 5 over 21 is approximately 0.2381, which as a percentage, multiply that by 100%, which will move the decimal over 2 spots, and you'd get 23.81%. So I needed to know how many guys were in the room, how many students were in the room, divide to get a decimal, convert that to a percent. And that's great, but that has nothing to do with the PCs and households in the sense that those numbers are wrong. So what do we do on this problem? Well, if we want to know what percentage of households have PCs in 2017, we need to know 2 things. We need to know when T equals 17, how many of those households have computers in them. That would be C of 17, and that would be like finding the numerator right here. And then we also need to know how many households were there all together. So that would be H of 17, and that's like saying how many students were in the room. But in this case, I can't just count. I have to plug into those functions up above. So I'm going to plug a 17 in here to get C of 17, and then a 17 there to get H of 17. So let's see what we get. So with C of 17, we get 2.99 times 17 plus 63.88, and for H of 17 it would be 1.70 times 17, just plugging that in place of the T, plus 105.96. If you go to the calculator for the 2 of those, you get 114.71 million households with computers, or PCs, and you get 134.86 million households altogether. Neither of those is the answer to the question. This number is like our numerator. This number is like the denominator on that what percentage of the students, were male question. So now when I want to answer this question and get to the percent, I'm going to need to do that division. So I'll take how many households had computers, 114.71. I'll divide that by how many households were there, 134.86. And let me go ahead and do that for you on the calculator so you see the way that I think about this. 114.71 divided by 134.86. And when you think about how many decimal places should I write here, a lot of people round to the nearest hundredth of a percent, and they think, okay, so I need to go 0.85, because that's the nearest hundredth, tenths, hundredths. But this isn't a percentage, this is still the decimal. If you want to see the percentage, you have to do times the 100%, and this would be the percentage form. So then this is tenths and hundredths. So in percentage form, that's the hundredths. So that's the last digit I want to write. So I'll do that in the decimal. I'll write that same digit up here, which is that 5. But when I go to write that 5, I have to look at the digit after it, which is an 8. So I round up, and that becomes a 6. Then I multiply by 100%, and that becomes 8.056%. And then I have tenths, hundredths, and that's what they asked me for, was to the nearest hundredth of a percent. So be careful with that. When they tell you to round to the nearest hundredth of a percent, make sure you don't round to the nearest hundredth until first you get the number into that percentage form that they were asking for. All right, moving on to number 5, the percentage of households in various income groups that shop at Flinty Thrift is shown in the table to the right. Let f of D be the percentage of households with an income of D $1,000 that shop at Flinty Thrift. Use regression to find an equation for f and write the equation using 2 decimal places. So when they say that we're going to use regression, that implies we're going to enter the data into our calculator into L1 and L2 and then do the regression that way. So one of the things that's a little confusing at first about this problem is it has 3 columns. So we have to think about which columns are the information that we want. They say let f of D be the percentage of households with an income of D dollars. Right here it says this is the percentage of shoppers that shop at Flinty Thrift, so this is the percentage column. So this is going to be our f of D's for this. And then so D is thousands of dollars, so we have that kind of here twice. Here's the income, though this is kind of written out, it's kind of a strange mixture of thousands and the whole number written out. But when you have a range, you can't enter that into your calculator. So the common thing that they do is they'll use the midpoint. So roughly halfway between 0 and $19,999 would be $10,000. So this is that value of D in thousands of dollars. So these are going to be my values of D right here. And when you're doing regression and you're going to the calculator, you can always tell in function notation what your input variable is because it's inside the parentheses. So D is the input variable, so that will go into L1, and then these f of D's are like the y, so they'll go into L2. So let's drag the calculator into the process, and we're going to hit the Stat button. We're going to go into the Edit menu, and we're going to enter those values of D into the first list. And then in L2, we'll enter these values right here. And we see that those are going down, which kind of makes sense in a way, that if you were higher income or higher income over here, that maybe you'd be less likely to shop at the thrift store. So notice that there's some pretty wealthy people still shopping at the thrift store. So we're not saying they don't, but it's just maybe a little less likely as your income goes up. All right, so next we want to do regression. So we're going to hit Stat again. I'm going to go over to the Calc menu. And then we want to do linear regression, which is right there. And I want to make sure that I'm telling it where I put my data. So I put my inputs in L1, comma, second L2 for the outputs. And then I'm going to press enter. My calculator is set up to give these R and R squareds, which is more of a statistical thing. If yours doesn't show that, don't worry about it. You just need the equation. So for the equation, you need that number in front of x, which would be the slope, and they're giving you that. And you need that b for the y-intercept piece, and they're giving you that. So these other numbers we'll talk about later on in the course. You don't need them for this upcoming exam. So if yours doesn't have that, don't let that stress you. If it does, that's fine too, but we're not using them for now. All right, so let's start writing this stuff down. So what we normally want to do is write a y equals mx plus b sort of thing. And they said to use 2 decimal places. So this first number is my slope. If I round that to 2 decimal places, that would be 0.34 because that second 3 is followed by an 8 times x plus b, and b is 77.66 if I wrote it to 2 decimal places. And then that's fine to write it in that format because that's what the calculator was showing. But they actually didn't ask us to use those variables. They asked us to use d as the input and f of d as the output. So then I'm going to translate that into the way they had asked for it and say my output is f of d, and that is approximately equal to negative 0.34 times our input variable, which according to this would be d. It's an important thing to remember. Whatever's in parentheses is your input variable and has to match on the other side. And then plus 77.66. All right, so there's the equation that they wanted. So now let's move on to the next question. What percentage of households with an income of $28,000 shop at Flinty Thrift and round to the nearest 100%? All right, so we need to figure out what is the value of D here. And they're saying 28,000, but notice that this 25 was 25,000. So all we need from that is just the 28 part because this equation is already set up to be in thousands. So when we put in a D of 28, according to the way this chart was labeled, that would be 28,000 already. So we just want to compute f of 28. So when we substitute that here, we also have to substitute it there. So negative 0.34 times 28 plus 77.66, and then kind of messy, so I'll go to the calculator to see what that is. And I get 68.14, which is already a percentage because the values of f of d are percents. And then it just happened to come out to 2 decimal places. Let me bring that back in again, see, it's already 2. So 68.14, it's already a percent. It's already got the number of decimals that we want, which is 2 decimal places because they asked for hundredths. So that would be our answer for that piece. And then the last one, trickiest one, for what incomes do more than half of households shop at Flinty Thrift, and then round this to the nearest dollar. So let's see, they want more than half. So more than half. So you could say they want something to be greater than a half, but we don't really have fractions as our variable, we have percentages. So I would argue that more than half translates to greater than 50%. And if we're going to put 50% here, we need to put our variable that is percentage on the other side, which would be f of d. So this would be that the percentage of households that are shopping at the thrift store is greater than 50%. That is an equivalent to translation to saying that more than half of them shop there. The problem is they want us to solve for incomes, and this is already kind of simple and done, right? But it's not solved for incomes, it's solved for a percentage. So we need to somehow get the income d in there. So the way we do that is we go back up to this equation that we came up with that says f of d is equal to this expression, and we substitute this right-hand side in place of that f of d right there. So if we do that, we get on the left-hand side, instead of f of d, I'll write that equation up there, negative 0.34d plus 77.66, and then I just keep writing the rest of it, right? This was the f of d. Now I have the greater than 50. And then from there, I just want to solve for d, which would be the income level, and when I do that, I'll have my solution. So there's the variable d. There's a plus 77.66. Let's take that constant and move it over to the other side. So these will cancel. And then we simplify, so on the left, all that's left is the negative 0.34d, and greater than, add those two together, that would be negative 27.66. A little bit of a concern maybe if you're trying to solve for an amount of money and you've got a negative, but notice we have a negative on the other side too. So when we're trying to solve for d, our next step would be to get d by itself, so we would divide by this negative 0.34 to get these to cancel. But we'd have to do that on the other side as well, and then the two negatives would make a positive. The other thing that would happen, because we're solving an inequality and we took the step of dividing both sides by negative, is this inequality is going to switch directions on us and go that way. So now when we simplify, we have d by itself. Our inequality is now a less than because of that switch. And then we'd want to just take that and round it to the nearest dollar, which they asked us to do. So let's see, what's our division there? Negative 27.66 divided by negative 0.34. And when people hear that to the nearest dollar, a lot of times they think, all right, 81. But this is not in dollars, this is in thousands of dollars. So if I take this and go times 1,000, now it's in dollars. And now I could round it to the nearest whole number, and that would be dollars. So 81,352, but the 2 is followed by a 9, so we'll round that up to a 3. So it looks like you're going to get more than half of the people shopping at the thrift store when the income is less than $81,353. And then I would argue that makes sense too, that it's going to be more than half when the incomes are below a certain level, because we saw that as the incomes go up, the percentage goes down. So if we want the income to, or the percentage to be high, over 50, so where does that happen? Somewhere like in this zone, right? These are all over 50, and those people are all making less than 83,000. So that does kind of match up well with what we ended up having come out of the algebra process. All right, moving on to the last page. Find the perimeter and the area of the parallelogram shown to the right. Clearly label each answer and include the appropriate units. So they're actually asking us for two things, perimeter and area. So I'll label P for perimeter and find that one first. So one of the things that we want to remember about perimeter is it's just the distance around an object. So if you were to walk around this, you'd go 9 feet and then 20 feet, and then this side is equal to that one, so there'd be another 9 feet over here, and then you'd finish your path. We started here, right? 9, 20, 9, and then we'd walk another 20 to get back where we started. So when we add up the distances around, we're going to get that 9-foot distance twice, so I'm going to put 2 times 9. And we're going to get this 20-foot distance twice, so I'm going to say plus 2 times 20. And then just do those individual pieces, following order of operations, so we get 18 plus 40, and then add those together, and we get 58. And then we just need to think about what kind of units we would have on that. And when you're adding things, they don't change the type of unit. So 9 feet plus 20 feet plus 9 feet plus 20 feet is 58, and it's still feet. So if you were to walk around that entire parallelogram, it'd be 58 feet in total that you're walking. When we go to do the area, now we need to know the formula. And area is base times height for a formula. And the base is either the bottom or the top. I would usually think of it as the bottom, but they're equal, so it doesn't really matter which one you're thinking about. So 20 times the height, which isn't the slant height, but this straight up and down height. You might have wondered why we didn't use that for perimeter. And the answer to that question is because it's not one of the outside lengths when you walk around. But when you're doing the area, you need the height, which again is that straight up and down height, and they're telling us that's 6. And so then we do the 20 times 6, we get 120, and we'd want to think about what the units are. So it's 20 feet times 6 feet, so we get the 20 times 6 is 120, but the feet times feet give us feet squared. And that makes sense because area tends to have square units on it. So 120 square feet for the area and 58 feet for the perimeter. All right, moving on to problem number 7. Simplify 11x over 4 minus 2/3 minus 11 over 6 plus 7x over 8. So there's a part of me that says, hey, what's the LCD of all these? And I can think that through real quick. I think 24 would be an LCD for all those denominators. And hey, let's multiply by 24 and get rid of the fractions, because that's always nice to have the fractions go away. The problem is, this is not an equation, because there's no equal sign. This is an expression. So in order to multiply by 24, you have to multiply both sides by 24 to keep it balanced, but there aren't sides on this one. So unfortunately, we can't get rid of the fractions. We just have to work with them. But it turns out this is a little easier than you might think, because you don't need to get a common denominator for all of these pieces because they're not all like terms. When you're trying to simplify an expression, you're trying to combine like terms. So you would combine the x terms, and you would combine the constant terms, and you just need common denominator for the ones that you're combining. So let's write them grouped together better. So we would have the 11x over 4, and we want to combine that with the 7x over 8. That's part of what we'll do. And then we'll have the constant terms, which would be that negative 2/3 combined with negative 11/6. And when you want to combine them, they need a common denominator. But if you look at just the x terms, the common denominator is simpler than if you look at all 4 at once. So 4 goes into 8, which means 8 is the common denominator. If I multiply this by 2 on the bottom, it'll have a denominator of 8, just like that one. But for balance, if I multiply the top or the bottom by 2, I have to multiply the top also. Over here, if you look at these two, we don't need the 24 for the common denominator. 6 will do the trick because 3 goes into 6. So if we multiply top and bottom by 2 here, we'll get the 6 on the bottom, the 2 on the top, just to keep things balanced. So if we do that, then for the first piece here, we get 22x over 8 plus 7x over 8, but those are like terms, so we'll be able to combine them next. And then here we have negative 4 over 6 minus 11 over 6. I'm going to write that as plus negative 11 over 6 just to emphasize that I'm adding two negatives together. That's sort of optional, but I think that kind of helps emphasize that they're both negatives. And then we just do the addition. So These are both x terms on top, so 22 plus 27 is 29, and they would still be x terms, so 29x over 8. And then plus -4 plus -11 is -15 over 6. And we've combined like terms. These cannot be simplified because 8 and 29 have no common factors, but there's a couple things I can do here. When I have this plus a minus, I should just consolidate that and write a minus in the front. We don't like to have double signs. And then 15 and 6 have a 3 in common. So 3 goes into this 6 twice and into this 15 5 times. So after we do that reducing, we have 29x over 8 for the x term. We'll make that just a single minus sign out front, and then 5 over 2 for these pieces. There's no need to get a common denominator here because these are not like terms. This has an x and this doesn't, so we can't combine them anyways. So if we got a common denominator, this just wouldn't be simplified. So we're just going to go ahead and leave it just like that. All right, I hope this helps you as you're studying for the test. Good luck.